What if the air disappeared? All of it. In 1 second. What happens next? Does the world end in a bang? A whimper? To answer that, we do not need science fiction. We need physics. The universe is governed by laws. Those laws are unforgiving. They can tell us exactly what would unfold if our planet's life-giving blanket were ripped away. It would be a silent catastrophe, a cascade of events driven by the brutal realities of pressure, temperature, radiation. The transition from a living world to a dead one would be shockingly fast. We take our atmosphere for granted. We walk through it, breathe it, rarely give it a second thought. But it is an elaborate, multi-layered life support system. It provides pressure, about 101.3 kilopascals at sea level. That pressure keeps our bodies intact and keeps water liquid. It is a complex machine. Every part is critical. Its disappearance would reveal how much work it does every moment. Without it, living on the surface becomes impossible. The atmosphere is our reservoir of breathable gas. About 21% of the air is oxygen, fuel for cellular metabolism. The other 78% is mostly nitrogen, an inert diluter. Without air, the supply of oxygen is gone. The human brain can only function for about 15 seconds without fresh oxygenated blood. This is called anoxia. Earth's average surface temperature is about 15 degrees Celsius or 59 degrees Fahrenheit. That is much warmer than the expected minus 18 degrees Celsius or 0 Fahrenheit. The 33-degree difference is the greenhouse effect. Carbon dioxide, water vapor. Remove that blanket, and absorbed heat would rapidly radiate into space. Let's zoom in on those first few seconds. The atmosphere is gone. The pressure drops to a near-perfect vacuum. For any living thing not in a sealed container, the consequences are immediate and gruesome. This is the realm of explosive decompression. The gas trapped in your lungs would expand, and if you held your breath, your lungs would rupture. This is a primary rule for astronauts. This is a primary rule for divers. In a rapid depressurization event, exhale. But even then, the outlook is bleak. The gas dissolved in your blood and tissues would start to come out of solution, forming bubbles. This is like the bends, but happening everywhere in your body at once. The most bizarre effect would happen to the liquids on the surface of your body. At a certain low pressure, known as the Armstrong limit, water boils at human body temperature, 37 degrees Celsius. This pressure is about 6.3 kilopascals. In a vacuum, the pressure is far below this. The saliva on your tongue would instantly begin to boil away. The tears in your eyes would instantly begin to boil away. The thin layer of moisture on your skin would instantly begin to boil away. It is not a hot boiling, it is a cold boiling, as the rapid evaporation steals heat. Your blood inside your veins would not boil, because your circulatory system maintains its own internal pressure. But the effect on exposed tissues would be devastating. NASA has some accidental data on this. In 1966, a technician inside a vacuum chamber had his suit spring a leak. He was exposed to a near vacuum for about 15 seconds before being repressurized. He remained conscious for about 14 seconds, and his last memory was of the water on his tongue beginning to bubble. He survived with no apparent long-term damage, but it was an extremely brief exposure followed by immediate rescue. On a planet with no atmosphere, there is no rescue. There is no repressurization. Consciousness would fade within 15 seconds from lack of oxygen, and death would follow in a minute or two, and it would not just be living things. As you lose consciousness, one of the last things you would see is the sky turning black. Our beautiful blue sky is a product of Rayleigh scattering, nitrogen, oxygen. Shorter, blue wavelengths of sunlight are preferentially scattered. Without those molecules, there is nothing to scatter the light. The sky would become the same perfect, star-dusted black that astronauts see from the surface of the moon. The sun would not be a gentle orb in a bright sky. It would be a searingly brilliant, sharp-edged disk set against the blackness of space. You would be able to see stars and planets during the day. the familiar constellations, Venus, Jupiter, Mars. Sunlight would feel harsher, more direct. Shadows would become deeper and sharper, with no scattered light from the sky to soften their edges. This new view would also bring a new danger. Without the protective layers of the mesosphere, stratosphere, the surface would be exposed to a constant rain of micrometeoroids. Tiny grains of dust and rock, no bigger than a grain of sand, constantly bombard our planet. Our atmosphere incinerates hundreds of tons of this material every day. Without that shield, they would pepper the surface at cosmic velocities. You would not be hit by a large, world-ending asteroid, but the ground would be constantly scoured by these tiny, high-speed projectiles. There would be no sunsets, sunrises with their brilliant colors, as those are created by light passing through a thick cross-section of the atmosphere. The transition from day to night would be instantaneous, like flipping a switch. With the atmospheric blanket gone, Earth's climate system would collapse. The first paradoxical effect would involve the oceans. With the pressure suddenly gone, the surface of the oceans would begin to boil. This would not be a rolling boil like in a kettle. It would be a violent, cold boiling and rapid evaporation. A massive cloud of water vapor would erupt from the sea surface, which would then be lost to space. This process would rapidly cool the surface water, and after an initial chaotic period, the boiling would slow and then stop as a layer of ice begins to form. The long-term trend is a one-way trip to a deep freeze. As we know, without the greenhouse effect, Earth's equilibrium temperature would plummet towards minus 18 degrees Celsius. But it would not stop there. That temperature assumes the Earth is still absorbing the same amount of sunlight. As the oceans freeze and the land is covered in frost and snow, the planet's albedo, its reflectivity, would increase dramatically. A white, icy surface reflects more sunlight back into space than dark oceans and continents do. This would cause even less heat to be absorbed, pushing the temperature down even further. The planet would resemble a larger version of Mars or the Moon, with extreme temperature swings. In direct sunlight, the ground could still get warm, but the moment the sun sets, that heat would radiate away into space, with nothing to stop it. Nighttime temperatures would plunge to well below minus 100 degrees Celsius, possibly even colder. This is exactly what happens on the Moon, where daytime temperatures can reach 127 degrees Celsius, and nighttime temperatures drop to minus 173 degrees Celsius. Over a longer timescale, the oceans would freeze solid from the top down. The surface would be a shell of ice many kilometers thick. Only near geothermal vents on the ocean floor might liquid water persist, insulated by the miles of ice above and warmed by the planet's internal heat. If this is blowing your mind, like the video, subscribe, and share it with someone who loves science. For life on the surface, the end would be swift and absolute. Every unprotected human, animal, plant would be dead within minutes from the combination of decompression, anoxia, and flash freezing. The biosphere as we know it would be completely sterilized. The chain of events is so rapid and so total that there is no room for adaptation. It is a hard stop. But could anything, anywhere, survive this planetary catastrophe? The answer is a tentative yes, but only in very specific, isolated pockets. Survival would depend on being completely isolated from the surface environment. Humans could, in theory, survive in pre-existing, sealed habitats. Think of the International Space Station, but on the ground. These habitats would need to be airtight, structurally sound enough to withstand the internal pressure pushing out, and equipped with their own power, air recycling, food production systems. An underground bunker, a deep-sea research station could also work, as the rock or water above would provide shielding from radiation and micrometeoroids. These would be tiny arcs on a dead world. These shelters would be fragile islands of life. They would depend entirely on technology, and any failure would be catastrophic. It is the kind of scenario engineers for Mars missions plan for. We have the basic technology, but sustaining a population for generations in such a closed system would be an immense challenge. The survivors would be prisoners on their own planet, their existence a constant struggle against the hostile vacuum just outside their walls. In the end, the sudden disappearance of our atmosphere drives home a fundamental truth. Earth is a spaceship. The atmosphere is its life support system. It provides pressure, air, warmth, and protection. We evolved to live within its specific parameters, and we cannot exist without it. It is not just the air we breathe, it is the entire system that makes our world a vibrant, living place in the cold emptiness of the cosmos. The scenario is science fiction, but the lesson is real. Our thin, fragile layer of air is the only thing that stands between us and the void. Earth's atmosphere is not just air, it is a planetary life support system. Without it, Earth becomes a silent, frozen world. Comment below, what surprised you most? If you found this helpful, like the video, subscribe to Doubts Undertaker, comment with your questions, and share it with someone who loves science. Let's answer the unthinkable, with real physics, real data, and real science.